Hello, my dear students. First, I will introduce myself to you. I am the new physics teacher, Hamad Bahar. We will spend surely a perfect year. In this year, we will learn three units. The first one is about mechanics, and the second one, which is talk about electricity, and finally the third unit, atoms and nucleus. The first unit, which is mechanics, includes three lessons. The first lesson talks about energy, and this lesson you should have an idea about it, about kinetic energy and gravitational potential energy or elastic potential energy and mechanical energy. The second one, which talk about linear momentum and mechanical oscillations, and those two lessons are new, but they are very exciting and you will love it. The second unit, which is electricity, includes two lessons. The first one is electromagnetic induction, while the second one talks about alternating sinusoidal current. The first lesson talks about magnetic field and how can we make electricity without using a dry cell or a generator, while the second lesson talks about the voltage and current, and it's very simple, and it remembers us by the alternating sinusoidal current voltage in grade 9. The third part, which is atoms and nucleus, includes two lessons. The first one, atomic nucleus, and the second one, radioactivity. In general, this unit is a new, but it talks about many attractive scientific ideas, so be ready for it. Now we will revise some important lessons from grade 11. We will start in work and energy. The objectives of this lecture is to distinguish between deformable and non-deformable systems. The second objective is to distinguish between internal and external forces and to define the work of a constant force, and finally to distinguish between motive and resistive work. Now I will explain to you the difference between deformable and non-deformable systems. And you should know if this system is deformable or non-deformable after this lecture. First, the deformable system. As a definition, a system is deformable if during its motion the distance between at least two points changes. For example, the figure we are looking at it shows to me two pictures. The first one is a spring and two objects is attached to its extremities of masses m. The second picture shows me a force is applied on one of these two objects. As a result, the spring is compressed and the distance between the two objects is decreased. So, the distance between those 2 points has been changed, so this system is considered as a deformable system. For another example, as a students in the break, the distance between each two students is changing with respect to time. So the system students Earth also is considered as a deformable system because the distance between any two students is changing with respect to time. On the other hand, there is a non-deformable system. As a definition, a system is non-deformable if during its motion the distance between any two points remains constant. For example, the wheels of a car. As the car moving on the street, the distance between the four wheels remains constant during its motion. So we conclude that the system wheels Earth is considered as a non-deformable system since the distance between the four wheels remains constant during time. Therefore, as a conclusion, when the distance between 2 points of a system change, then this system is considered as a deformable system. But when the distance between any two points remains constant, so this system is considered as a non-deformable system. Now I will explain to you the difference between internal and external forces. As a definition, the forces that are external to a system are those forces exerted on the system by agents that don't belong to the system. For example, the weight force, the magnetic field force, the electric force, the normal, the tension, the friction, etc. As we see in this figure, a man is pushing an object. So, as a result, the force that exerted by the man on this object leads to the motion of this object. So this force is considered to be as an external force. While on the other hand, the internal forces as a definition are the forces that are internal to a system are the interaction among the part of the system. As we see in this figure, the spring is be elongated and compressed due to an internal forces applied from its part on it. So, this force is considered to be internal forces since there is no external agent applying the force on it. It is moving, it's compressed and elongated by itself. Now I will talk about the work of a constant force. First, you must know that the force done by object on another object may cause a work, may not. How? If there is a displacement, then there is a work. For example, here a boy is shooting the ball. The force exerted by the boy on the ball leads to change in its position from one position into another position. Then there is a displacement. Then the force here makes a work. While if there is no displacement, then there is no work. For example, here a boy is pushing a wall. The force exerted by the boy on the wall will not lead to a change in the position of the wall. Then there is no displacement. Then this force exerted by the boy has no work. As we talked in the previous slide, that the force may cause a work, may not. But if it causes a work, we must calculate it and know on what it depends. So, the energy transferred to a system by a constant force F, and therefore the work done by this force between two particles depends on first, the magnitude of this force, second, the displacement d of its point of application between these two particles, third and finally its direction, determined by angle alpha between the direction of the force and that of the displacement. So as a result, work equal F times D times cosine angle, where F is the magnitude and D the distance, and angle it is the alpha between the direction of the force and its displacement. Final point today is how to differentiate between motive and resistive work. As I explained in the previous slide that work equals force times distance times cosine angle, so it depends on the angle. Here, the motive work is said to be motive when the energy has been transferred from the environment to the medium. In this case, the angle is between 0 and 90 degrees. As we see in figure, there is a boy pushing a gear. So, the direction of the force of this boy is with the direction of motion of gear. As a result, when the direction applied and the object has the same direction of motion of this object, so the work done is motive. Why the resistive work is said to be resistive when the energy has been transferred from the medium to the environment. In this case, the angle is between 90 and 180 degrees. As we see here in the figure, a goalkeeper is stopping the movement of a ball. So the direction of the force applied by the goalkeeper is opposite to the direction of the motion to the ball. So in this case, the work done by the force of the goalkeeper is considered as a resistive work. Thank you for watching.